We love riding steel, that unique ride feel, the bomb-proof durability, and that classic timeless look. It's a material that's been around for thousands of years, and it's the first material that bicycles were made out of, and it continues to evolve with new innovations. Yet all steel frames aren't the same. There's a number of factors that distinguish them: the design, the fabrication, and the type of steel tubing. What's up? I'm Zach Gallardo. Life is short, but don't make it shorter, so be sure to ride your bike every day to be reasonably dangerous, and consider hitting the like button and subscribing to watch more fixed gear and cycling videos just like this one. There's a lot of different types of steel tubing, from generic high-carbon steel tubes to unique alloys from well-known suppliers like Reynolds and Columbus. Wabi mainly uses two types of steel tubing, either Reynolds 725 or Columbus Spirit, to deliver the right combination of being lightweight, durable, fun to ride, all at a reasonable price. I'm here to help you understand what goes into different steel tubings and how it affects the ride quality of your bike. We'll start with three main characteristics: the steel alloy composition, how the steel is treated or worked, and the tubing profiles, and then explain why all of these big topics matter in a nutshell. Keep in mind that this is going to be a technical discussion of steel tubing and why it matters to you and me. First up, the composition. All steel is similar to a certain extent. It's made up of the same core material, iron, with up to 2% carbon. But the properties of steel can be drastically changed by adding varying amounts of carbon while adding elements like chromium and molybdenum. These elements change the characteristics of steel that are important to a bike frame, including better strengthness to weight ratios, increased hardness for durability, better formability for drawing thinner and thinner tubes, and increased resilience for both the liveliness of the ride quality and the durability of steel bikes. Chromoly is probably the alloy of steel that we're all most familiar with, given its prevalence in the bike industry. Invented in the late 19th century, chromoly contains the additions of chromium and molybdenum, thus chromoly. You'll often see it as chromoly 4130, an industry standard which speaks to the actual ratio of these elements along with carbon in the alloy. Both elements provide a good improvement in terms of strength and hardness and can be found in BMX bikes and mid-tier bicycles and parts. Higher-end alloys can contain even more unique elements like silicon, manganese, titanium, or copper, which can provide additional strength, hardness, and resilience. That allows for even thinner tubing walls to be used to make a bike exceptionally light. For example, Columbus Spirit, the tubing used in the Wabi Lightning, has niobium, manganese, and nickel to create an exceptionally lightweight yet strong alloy. Some tubing is even stainless steel to prevent corrosion, but bikes made out of these exotic materials do cost a pretty penny, due to the cost of the material itself and the skill that's required to make these tubes into a functioning, reliable bike. Next up, how the steel is treated or worked can also influence the ride characteristics, weight, and durability of a steel frame set. Once the tube is formed, these alloys can be heat treated to further improve their strength and durability. High heat is applied to the tubing, which alters the molecular structure of the steel. Heat treating can improve the strength of steel by up to 50%. This means that heat-treated steel tubing can be significantly lighter than its non-heat treated equivalent because it has a much better strength to weight ratio. For example, the Reynolds 725 tubing that's found on most Wabi bikes is a heat-treated 4130 chromoly steel and is significantly lighter than Reynolds 525, which is its chromoly 4130 counterpart. The thinner walls of Reynolds 725 can also provide a livelier ride feel than the stiffer walls of the non-heat treated chromoly. Then there are other terms like seamless, cold worked, or air hardened that describe the tubing. Some of these are more relevant to the consumer, the people riding the bikes, while other terms are mainly useful to the manufacturer. Air hardening is another term that you're likely to see in more higher end steel tubings. Air hardening essentially explains how the steel is cooled and hardened after it has been formed or welded. Air hardening is an alternative to oil or water cooling, aka quenching, and with certain alloys gives improved hardness while limiting any deformation of the steel. For bike builders, air-hardened steel will form a strong bond at the weld areas. Generally, air-hardened steel, either by itself or as air-hardened and heat-treated steel will be a stronger and harder type of steel. For instance, Reynolds 631, an air-hardened chromoly, is 10% stronger than its non-air-hardened equivalent. The last important piece is the profile, or the shape of the tubing itself, which also includes the butting. Most tubing profiles are circular, with some exceptions for the chainstays and forks. The seat stays are also usually circular and have smaller diameters, and they can be tapered on one or both sides to optimize the strength to weight ratio and provide clearances for connections to the main tubings or for dropouts. The chainstay can either be circular or oval, as well as a curved or angle shape to provide proper clearances for tires and cranksets. Lastly, forks come in both circular or oval shapes depending on the needs of the maker. They will also come in predetermined shapes or rakes depending on the geometry needs of the frame. The tubing may also be butted, which is the process of thickening the walls of the tubing, usually inside the tubing where the tube meets the joints of the frame. This allows the tubing to be strengthened at the highest stress points while leaving the center of the tubing thinner to allow for a better strength to weight ratio. It also allows for more material to be at the ends of the tube, which makes it better for TIG welding. Usually you'll find butted tubing on the main triangle, the top tube, down tube, and seat tube. The butting on the main triangle makes a bigger impact since these are the biggest tubes on the bike, and the larger diameter of these tubes allows for this butting to take place. The diameter of the tubing and the butting work together. For instance, on the Wabi Lightning's main triangle, the top tube has the smallest diameter and thinnest walls, given it has the lowest stresses of the main triangle. The down tube has the biggest diameter since it has the highest stresses, and the C tube has a higher thickness so it can handle stress, and so it has enough material to weld the stays. Here are some butting terms that you may see. Straight or plain means that there is no butting. This is common for the head tube where you don't want to change in thickness because the headset needs to be inserted. Single butting means one side of the tube has additional thickness. This is common in the C tube where you want that thickening at the bottom bracket shell weld, but don't want it at the top where the seat post inserts. It can also be found in some chainstays and fork blades. Double butted is one of the more common terms, and it means that there's two thicknesses in the frame tubing with equal thicknesses on each end of the tube. This is common in the top tubes and down tubes. Triple butted means that there's three different thicknesses inside the tube, usually with different thicknesses at either end of the tube. This is to optimize the thickness at certain joints while minimizing weight. Like double butted, this is mainly used in top tubes and down tubes. Not all tubing is alike. There are differences in thicknesses used between the center of the tubings and the ends, and the types of butting can impact the way a bike feels to ride. Too much butting will make a bike feel stiff. Typically, higher quality branded tubing will use tapered shapes that balances the strength to weight ratio while maintaining optimal resilience and liveliness. Then there's the thickness of tubing. It can vary depending on the alloy treatments and the profile. Lighter, more responsive frames tend to be thinner walled because they are using high quality alloys that are heat treated and butted. For example, Wabi uses all three in tandem to give their bikes that delicious, lively, and smooth ride quality that steel is known for. Now let's take a look at how these factors come together into different categories and brands of tubing that you'll commonly see. Keep in mind that these aren't clear-cut categories, but rather steel tubing is more of a spectrum. But these categories will give you a decent guideline. High-ten steel, short for high tensile steel. This high carbon steel is what you might find on low-cost steel bikes. It's characterized by its heavy weight, stiffness, and low cost. The steel typically isn't branded since it's a commodity product. High 10 is high 10 wherever you go. And you can see my experience of trying to ride a high tensile steel bike 100 kilometers by sticking around until the end of the video. Chromoly steel. This is the most widely used tubing for many low-end to mid-range frames. It's a good quality alloy steel that's lighter than high 10, and it may also come as double butted, though the butting may only be a simple single step butting. Like we talked about before, air hardened chromoly like Reynolds 631 will provide a slightly stronger and lighter frame compared to non-air hardened variants. So it's helpful to think of air hardened chromoly as a small step up from regular 4130 chromoly. Then we start getting to the stuff that I really like, the heat-treated chromoly. Heat-treated chromoly may also be combined with air hardening with certain brands, though even that is sometimes restricted to even higher end alloys. And these tubings will almost always be double butted since they are very high quality frames. Wabi uses heat-treated chromoly, Reynolds 725, in almost all of their models. Why almost all their models and not all their models? Well, that brings us to the really nice fancy stuff. These are the heat-treated specialty alloys. These are tubings that combine more unique alloys, heat treatments, and high-quality double or triple buttings for even better strength to weight ratios. Wabi uses a heat-treated specialty alloy, Columbus Spirit, on their Lightning frame. For an oversimplification that's nonetheless helpful, heat-treated specialty alloys are very lightweight, top-tier tubings. Heat-treated chromoly are lightweight, high-tier tubings. Chromoly is the most widely used steel and ranges from mid-tier to low-tier, depending on how it's used, and high-10 steel is low-tier, heavy stuff. There's a lot of factors that go into steel tubings for frame sets, depending on your preference for strength, weight, stiffness, ride quality, and price. Frame designers and builders need to balance steel's composition to ensure the frame set is strong enough without being too heavy, with how the steel is treated to improve durability without adding weight, with the profile of the tubing to ensure there's strength, stiffness, and responsiveness in the right areas of the frame. But tubing is only one part of the bike building equation. These tubings need to be put together in a well-designed geometry and fabricated skillfully to bring them to life. A high-quality frame and overall build should take all these factors into consideration to work together for an amazing ride. Be sure to subscribe to the channel so you can catch the upcoming video on geometry. And check out my video where I build up the Wabi Thunder, which is made out of heat-treated chromoly, to see how a bike of this caliber functions and rides in the real world.